Today we're going to talk about Hooke's law. This is part of simple harmonic motion, sometimes known as periodic motion. Some keywords here that we have discussed in the classroom: compressed, stretched, constant, oscillation, pendulum, displacement, proportional, restoring force, equilibrium, lots of stuff. Compressed means squashed together. Stretch is when there's pulled further apart. Constant, no change. Oscillation means it's moving backwards and forwards. A pendulum is like a ball on a string and it's moving sideways, back and forward, back and forward. Displacement is how far away you are from the beginning, like a distance. Proportional means if, for example, one increases, the other will also increase. That will be directly proportional. If one increases and the other decreases, that will be inversely proportional. It's a relationship between two things. Restoring force is the force that tries to bring an object back to the center again. If I lift a ball up, gravity will restore it back to the middle again. That's what it tries to do. If you pull on a spring, like a block on a spring, the spring will restore it, try to bring it back to the middle. The middle we call the equilibrium position. Okay, there were a couple of formulas that we did go into with periodic motion, because we know periodic means it will repeat itself over and over again. This ball is going back and back and back all the way, every day, all the time, 24/7. A bit boring for the ball, but that's what happens. If you wanted to find the frequency, you can easily do that by finding the one motion divided by the time it takes to make that motion. That will be the frequency. That means how many times it will happen. So it means that one motion, so starting from the middle, going all the way up, all the way back, and then back to the middle again. How long it takes, we call that the period. Okay, the time it takes to go 1, 2, back to the middle. And you could do 1 over t, or you can rearrange this. You can swap the two positions, and you can find the period itself if you know how many times. So if I, for example, in 1 second, if it moves backwards and forwards 2 times, I can write 1 over 2, and the period will be half. Yeah, so that means every half a second you will get a full movement. This is amplitude and frequency. Period and frequency. Okay, so simple harmonic motion, the meaning of this is when a restoring force tries to move an oscillating object back to the equilibrium position. If you pull on the spring with this block, it will pull backwards, and he will end up being pulled back because of the spring to the center. But because it applied a force, he will actually keep going. It will get compressed, and then the spring will try to push it back forward again, and then backwards and forwards and backwards and forwards, and it'll just keep repeating itself. Same idea with a pendulum. There's a little bob, which is the ball at the end of it. It will swing backwards and forwards because gravity brings it to the middle. When it gets to the middle, gravity will stop. But then what happens is, because it already has the speed, he will keep going, and then gravity tries to bring it back to the middle again. So it's going to keep doing that motion over and over again. We did a simulation in class. You can go back and check on the class kick if you like, or open up this link and you can play around with it yourself. We came up with a formula to help calculate the force, whatever this restoring force will be. It's F equals negative kx. K is the strength of the spring. This is mainly for springs. It's the strength, how strong the spring is. We call it a constant. And we'll multiply that by the displacement, how far away it has gone. There is a negative here because we know that it will be the opposite. If I take my spring and my block, and let's say the block, I move it to here. This is my displacement from here to here. This is in the positive axis, because right is positive, left is negative, right? So if he's gone to the right, the force, the spring, is trying to pull him back to the left again. It will be minus. Similarly, if the block is on the left hand side and he wants to be in the middle, right here, this is the negative x now, he's in the -1, -2 or whatever, the force will go to the right, which becomes positive. So you can see that the force is always acting in the opposite direction of this displacement. But usually in your calculations you will be wanting to find the magnitude only, the size only. Okay? And another way to do it is if a spring is hanging from the roof, you attach a mass to it. You can find the mass easily You can do this W equals mg. This is a rule that you know from before. W equals mg. G is gravity, which is 9.8. So you multiply the mass by gravity, that will tell you the force of this going down, and then of course this spring is trying to pull it back again. So that's how it works. If you were to make a graph of it, you will get a straight line going through the origin, and this straight line, if you find the slope of the graph, you find out that this is actually k. Yeah, rise over run, delta y over delta x, n over x, that's force divided by displacement, and that is your constant. Amazing stuff. So why does it eventually stop when it keeps going? We have friction or we have air resistance. These things will make this stop. You did an experiment on this. If you were to do this, you will see a little graph going up, and eventually it will break. The spring will stop working. It'll go beyond its limit, beyond its elastic limit. This is when it will stop obeying Hooke's law, and you cannot do any more calculations. It will not return back to its center place again. So this is beyond the limit of elasticity. Okay, so we know that the restoring force is proportional to the displacement. If you pull it twice as far, the force will be twice as long. So spring in this situation is the restoring force. So why is it moving backwards and forwards, assuming there's no friction or air resistance? Well, let's think about it. When it's pulled, the spring wants to pull it back. So it starts at rest, it will start to accelerate. So the speed here would be 0. It will get faster and faster and faster until it reaches the middle point. So it's speeding up here, and then it reaches the middle point, the spring will relax, it will stop. But it already has a speed, so he's going to keep going. This is Newton's law, Newton's first law. He will keep going unless something stops him. So the block will keep moving, and then the spring will realize, oh no, I have to push back. So the spring will compress and push the block back. He will slow down, stop, and then he'll speed up again in the other direction, and the motion will keep repeating itself. You'll see in the middle, the kinetic energy will be the highest. This will be the highest kinetic energy, and on the sides you'll be the highest potential energy, stored energy in this case because of the spring. Same applies to a pendulum, but we'll get to that. We did some practice questions. I reminded you about the formula. We did some practice examples with this. We will do this in another video. Okay, we'll go through these examples in another video. So this is what we did, and that's all you need to know really for Hooke's law. There is actually one final thing before we go ahead. If you wanted to find the area under this for any reason, you turn this into a little triangle and you calculate this area. If you remember how to find the area, it's a half base times height. Yeah. If you did that, you would actually find the energy. Energy. Which is really handy. That will take us to a formula, the potential energy. A half times the base times the height. Or the height times the base, it doesn't really matter. It's a half of this times this. F multiplied by x, or x by f. Same thing. This is the potential energy. If you did not know the F, we can substitute F equals kx into this formula again. F equals kx. So you can put kx multiplied by x. X times x is x squared. So you can do a half fx or a half kx squared. This second part is very useful if you did not know the force. So that will be very handy for you to find the potential energy. Okay? Very good.